Good day everybody, we are being given a beautiful question. We are expected to find the area of the green shaded region. So I would like to draw the quarter circle first, and then we will move on from there. So this is what we have been given. This is OA, and from A there is a hit. Right from A we got a hit at this point B, and AB is 12 units. Now from B there is a hit. I gotta be careful when I'm drawing this point. So okay, so this is taken to be as T units, and there is a 90 degree there. Now BT is given to be as 5 units, and we are expected to obtain the area of the green shaded region, which is OABT. Right? So now what I wish to do is, I would like to, since I have a 90 degree, I am going to connect these 2 points and form a right triangle. Right? So this is a right triangle. Now why do I do that? I want to know this side. Now clearly you can see that the green shaded region is divided into 2 triangles, and the solution is complete if I am able to get this side and this side. So foremost, what I wish to do is, I would like to make the following observation. On observation, we see that I should start with triangle ABT is a right angle triangle or right triangle. Therefore, by Pythagoras, we know that, what do we know? AB squared plus BT squared is equal to AT squared. AB squared is 12 squared, BT squared is 5 squared. So therefore AT squared is equal to 12 squared is 144, 5 squared is 25. This gives us 169. So therefore AT is equal to root of 169, which is equal to 13. So this is taken to be as 13, or we have found that to be 13. Now what I wish to do is, I will have to stretch this, right? I will have to stretch this so that it meets the point, the diameter. So I need to do that. I need to be a little bit careful in doing that. Okay, so that is stretched, and we have a diameter. So this is going to be my diameter. Now I will have to complete the circle. So let me complete it. So it starts here. Okay. That's it. Okay, it's okay. This is a complete circle, right? So please ignore the slight distortions because I don't have a compass here. So we have got that. Now if I were to take this as some Q, what do we see here? Clearly AQ is the diameter of the circle, right? That's an observation. And you see that O is the center point, and whatever that is happening onto this quarter circle can be reflected onto this circle, and that would mean also we see that, what do we see? AT is equal to TQ, right? Now AT is equal to 13, so this means TQ is equal to 13, right? Why? This is other half of the circle, and by reflection we can simply conclude that TQ is equal to 13. So I've got TQ. Now what I wish to do is I would like to apply Pythagoras again. Now this time, okay, we now consider triangle ABQ, and you have a 90 degree here, and by Pythagoras theorem, what do we get? What do we get? AB squared plus BQ squared is equal to AQ squared. So this means AB squared is 12 squared, and you have this side 5 positive 13, that's going to be 18. So 5 positive 13 squared, which is equal to AQ squared. So AQ squared is equal to 144 plus 18 squared. So what is 18 squared? 18 into 18, 64, 6, and then 14 and a 8 and a 1, 8. This is 4, and 8 added to 4 is 12, 1, 3 to 4. So this is going to be 144 plus 324. You add 144, 8 and 6, 468. So AQ squared is 468. Now we need to get AQ. So therefore AQ is root of 468. Right? Now we can actually take the square root. Now if I were to take the square root, if I were to use 4 divides this 468 one time, and then another one time, then 7 times. So this is at the most, if I were to use 3 now, 3 divides here, 3 3s are 9, right? 3 3s are 9, 10, 11, and 9 times there, right? So this can be rewritten in the following fashion. Let me rule that 4 multiplied with 117, this can be again rewritten as root of 4 times 117. I'm going to write it as 3 times 39, right? 3 9 3s are 27 through, 3 3s are 9, 10, 11, that's fine. Now 39, I can write 39 as 3 multiplied into 13, right? 3 3s are 9. So if we were to take the square root, it's going to be 2 times 3 times the root of 13, right? Which is equal to 6 times root of 13. This is what we are getting. So this entire quantity is 6 times root of 13, but we need only this part, right? So that's going to be, this part has to be divided by 2. That's going to be 3 times the root of 13, right? So we know this part, we know this part, and clearly this is 90 degrees, right? So if I'm going to take T1 and T2, area of the green shaded region is equal to area of T1 plus area of T2. So I need to get the area of this part. So let me use the other page. Now clearly you can see this is a right triangle, and you can, if you know this side, you can use the base into height formula, right? So that's exactly what I'm trying to get at. What I'm trying to get at is I'm going to get this side, OT. So by Pythagoras, let me write that. Consider triangle. I'm going to consider triangle TOA. So by Pythagoras is the most powerful theorem in geometry, Pythagoras theorem. So what do we have? We got OT squared plus OA squared is equal to AT squared. Now OT squared is required. OA squared is 3 into root of 13 squared, and AT squared is 13 squared. So this is going to be 13 squared. I'm going to push this to the other side, negative 9 into 13. Root of 13 squared will be 13. So if I were to take 13 out, you get a 13 minus 9, right, which is equal to 13 times 4, right? And 4 3s are 12, 1 4 1s are 4 5, 52. So OT squared is 52. So OT is equal to root of 52. That's a base. So we got the base to be as root of 52. So area of this is equal to half times base into height. So therefore area of T1 is equal to half times base times height. So what is base? Base is root of 52. And what is height? Height is 3 into root of 30. Now can I write 52 as, yeah, we can write this is equal to 1 over 2 times root of 52 is 4 times 13, right? 4 3s are 12, 1 4 1s are 4 5, that's okay. And you got a root of 13, so that's equal to root of 4 is 2 divided by 2, and you got a root of 13 times root of 13, which is going to give you 13. 2 gets cancelled, you're getting 13 square units. So this is for area of T1. That's a beautiful value. Now area of T2, what is that? This is the right angle, so this is the height and this is the base. So half times base into height. So it's equal to half times, my base is 5 units, my height is 12 units. 2 divides here, 6 times 6 5s are 30 square units, right? We need the shaded region. So this is the entire region. This is the shaded region we need. So therefore area of the green shaded region is equal to area of T1 plus area of T2. Area of T1 13, area of T2 30. This is 43 square units. Lovely. Can you believe that? We've just been given a chord, just one chord, right? Just a chord is given and a quarter circle. The only additional feature, a solace of consolation, is this: from the perpendicular which is dropped to the circle, we have a line, right? So of course we can consider it to be a sector, and probably if there is a question, find this region, then how would you obtain this region? Can you tell me? Right? So having mentioned that, this is a lovely question for the fact that so much little information has been given, and because we were able to draw the other side, we were able to obtain the area of this shaded region. Now what I wish to ask you all is, how would you get, if instead of asking this region, if they ask you this region, how would you get this region? Can you write that, or can you show me the steps in the comment section? Thank you everybody. Please subscribe to this channel. That's the way you can support our work and keep us motivated to provide more advanced features in geometry, thereby giving you more value and subsequently extending your power of imagination. Have a good day.